Pilots called it the Luftwaffenfeuerzeug, the Luftwaffe's lighter. The Heinkel He-177 Griffin, a massive 4-engine heavy bomber, had a fatal flaw. Its engines were crammed together in pairs, generating heat no cooling system could handle. Aircraft exploded on runways before ever reaching combat. Germany desperately needed aircraft to strike deep into Britain and hunt Allied convoys across the Atlantic. Then Heinkel's engineers finally cracked the code. Test pilots reported smooth flight and cool engines. On the night of January 21, 1944, a dozen Griffins lifted off from bases across France, their bomb bays loaded for London. Hitler wanted the capital to burn in retaliation for Allied raids on German cities. He was out for revenge, and he would have it, even if every Griffin had to fly over Britain in flames. In the 1930s, as the Third Reich grew at an unprecedented pace, Lieutenant General Walter Weber, the Luftwaffe's chief of staff, pushed time and time again for a true heavy bomber. Weber believed heavy bombers would be vital in any future European war, especially against Britain, as only long-range aircraft could strike targets across the British Isles, operate without support from Germany's small surface fleet, and hunt Allied shipping far out in the Atlantic. Though the German manufacturers produced 2 promising prototypes of 4-engine bombers, when Weber died in an airplane crash in 1936, his successors quickly pivoted to medium bombers for battlefield support. Nonetheless, that same year, Heinkel Flugzeugwerke received an official specification from the German Air Ministry for a new long-range bomber, capable of delivering a 2,200-pound bomb load across a range of 3,100 miles, all while still being fast enough to outpace the fighter aircraft then in service. To deliver this, Heinkel's chief designer, Siegfried Gunther, knew that conventional approaches wouldn't suffice, and the design would require revolutionary features, including engines producing at least 1,973 horsepower each. However, none existed at the time. Thus, instead of 4 separate engines like Allied bombers, the new model, the He-177, used an unusual coupled power plant design, with 2 engines side by side in each nacelle, connected through a single gearbox to drive one massive propeller. While this gave it the appearance of a twin-engine aircraft, it actually delivered 4-engine power, with each Daimler-Benz DB606A power plant pairing 2 DB601 engines. Gunther also proposed scrapping traditional radiators altogether in favor of an evaporative system that would let the engine coolant boil into steam, and condense it back into liquid through pipes running beneath the outer skin. Though cutting edge on paper, in practice, the paired engines ran so hot that the pipes warped, the coolant boiled off, and the system failed almost as soon as it was tested. Reluctantly, the entire system had to be completely abandoned and replaced with conventional radiator installations, a change that added thousands of pounds to the aircraft's weight while significantly increasing aerodynamic drag. Meanwhile, remote-controlled gun turrets, originally planned to keep gunners warm inside the cockpit, kept failing. Engineers ripped them out and installed man positions instead, each with a single 13mm machine gun and freezing gunners who needed oxygen masks and heated suits just to function at altitude. To add even more fuel to the fire, in 1937, Ernst Udet, the Luftwaffe's most vocal dive-bombing advocate, demanded that the bomber also dive-bomb targets for better accuracy. Though Heinkel protested immediately, explaining that an aircraft of this size and weight would never survive the structural stresses of pulling out from a dive, the request remained. When these mounting requirements accumulated, the bomber's gross weight was pushed far beyond original projections. Now Heinkel's engineers had to build landing gear that could hold up the bomber's immense weight and still fold away after takeoff. The first He-177 prototype, weighing an outstanding 52,734 pounds fully loaded, with fuel and test equipment, finally took to the air in November 1939, flown by Lieutenant Karl Franke, chief of the Recklen Flight Test Center. For a few minutes, the bomber climbed smoothly, its 2 giant propellers clawing at the sky. Yet after just a little while, the cockpit gauges began to creep into the red. When both engines were running hotter with every second, and the cylinder heads were edging toward failure, after just 12 tense minutes aloft, Franke had no choice but to bring the Greif back down. From there, engineers immediately set to work modifying the cooling system and increased the tail surface area by 20% to improve stability. A second prototype incorporating these changes began flight testing shortly afterward. However, during routine trials, violent control surface flutter tore the aircraft apart in midair, taking the lives of everyone aboard. Through 1940 and 41, more prototypes followed with similar fates. One of them crashed into the Baltic Sea when its controls failed during a dive, while another suddenly burst into flames during a simulated attack run in early 1941. Finally, prototype number 6, with production standard 2,700 horsepower DB606 engines, had an initial performance testing of a maximum speed of 289 miles per hour, a service ceiling of 22,966 feet, and an operational range of 3,417 miles. Though these engines still caught fire regularly, with pressure mounting of the now undeniably upcoming war, and no alternatives, production of the Heinkel He-177 Griffin began anyway. By 1942, with the war at its absolute peak, 3 dozen pre-production He-177s were sent to Luftwaffe units for operational trials. Results were mixed. Those lucky pilots who lived to tell about it said the aircraft handled beautifully in the air, with smooth controls, wide visibility, and steady flight, even through the roughest of weather. Yet these same men flew stressed, with one eye on the gauges, knowing any flicker in temperature or oil pressure could end their careers or worse. Even on the ground, mechanics faced their own ordeal, as the closely paired engines made basic maintenance nearly impossible. Reaching a single spark plug meant dismantling half the nacelle. By the spring, fundamental problems remained unresolved. Test flights continued, ending with emergency landings, engine replacements, and occasional total losses. Yet with the Eastern Front consuming resources, British bombers hitting German cities, and the Royal Navy operating with near impunity across the Atlantic, Reichsmarschall Hermann Göring refused to accept further delays and demanded immediate deployment. A total of 130 He-177A1 bombers had rolled off the production lines by June 1943. As finished, this massive, sleek bomber had a long glazed nose, a narrow fuselage, and a tall twin-fin tail. The model's forward fuselage compartment accommodated 4 crew members in increasingly cramped conditions. The pilot and co-pilot/bombardier sat side by side in the cockpit, while the navigator/radio operator and forward gunner occupied positions immediately behind them. A 5th crew member, the tail gunner, sat isolated in the rear fuselage section, connected to the rest of the crew only by intercom. However, from the get-go, operational deployment proved disastrous. Fewer than a third of the bombers were flyable. The rest were stuck on the ground with burned-out engines or waiting for repairs. While factories continued churning out the troubled variant, Heinkel's engineers desperately worked on improvements. Soon, a new model with a new dorsal turret and stronger engines finally gave it more power and better cooling, which they hoped would finally end the fire problem. But by late 1942, Germany faced bigger problems than faulty bombers. As the year reached its end, the Eastern Front had reached its turning point in Stalingrad. With the German Sixth Army trapped in the city and surrounded by Soviet forces, Göring promised it could be supplied by air. With this increasingly desperate situation, every available Luftwaffe aircraft was pressed into the effort, even models not designed for transport. For the Stalingrad airlift, instead of bombs, the He-177's holds were stuffed with crates of ammunition, barrels of fuel, and sacks of bread for the trapped Sixth Army. The bombers operated from frozen strips, carved out of steppe around the destroyed city. Lashed by snow squalls and choked with wreckage, ground crews lacked proper tools or spares. They patched bullet holes with scrap metal and wrapped engine lines in rags to keep them from freezing. Even then, many missions ended before they began. Engines coughed, overheated, and detonated on the runway, turning 50,000 pounds of aircraft and cargo into fireballs that lit up the night. Others clawed into the air, only to burst into flames over the Don River, crews bailing out into waist-deep snow while Soviet patrols closed in. The losses mounted at a rate of almost 1 aircraft per day. Every flight that didn't burn out in the sky risked being torn apart on the ground by Soviet artillery that now bracketed the forward strips. Crews who survived crashes faced an even grimmer choice: surrender to the Red Army or freeze on the steppe before dawn. In February 1943, with the unit's strength depleted to almost nothing and Stalingrad lost, the few surviving machines were withdrawn from the Eastern Front. By then, with their less than stellar reputation in their combat debut, crews began calling this model the Luftwaffenfeuerzeug, the Luftwaffe's lighter. The name stuck. Even the Führer had a direct bone to pick with the model. In a meeting with his military staff that same month, speaking to Colonel General Hans Stachionek, Chief of Staff of the Luftwaffe, Adolf Hitler stated, quote, "I have to say, again and again, I consider the whole 177 model a mistake, because it was demonstrated already during the Great War that the problem of installing 2 engines on one shaft is extremely difficult to solve and has led to constant difficulties." The model even earned another, more unfortunate nickname, the Flying Coffin. Around the same time, the A5 model, the first variant built in large quantities, entered production, featuring a longer wingspan and strengthened gear to address problems found in earlier models. Output began slowly in February, but rose sharply, with more than 400 delivered by the end of the year. That same spring, some were further modified to carry the HS-293, a radio-controlled glide bomb designed to strike ships from beyond their defenses. With up to 3 mounted under the fuselage and wings, the Griffin finally gained a standoff strike role that might keep it alive long enough to reach its targets. Through the spring and summer, the Griffin lingered in scattered trials and token sorties, never more than a sideline presence. Then, in October 1943, the bomber finally received prominent assignment when it was called upon to serve in Operation Steinbock, an ambitious campaign that would at last give the troubled Greif its combat debut over British soil. Adolf Hitler himself had ordered the operation as a direct reprisal for the mounting Allied bombing offensive against German cities like Berlin and Hamburg. Now, the Fuhrer demanded that London burn. Luftwaffe Supreme Command scrambled to assemble every available bomber, stripping units from the Mediterranean theater and the Eastern Front. In the weeks leading up to this operation, maintenance crews worked around the clock to prepare the motley collection. Approximately 80 HE-111s were pulled from training schools. DO-217s were hastily repaired after previous combat damage. JU-88s and JU-188s were scraped together from various commands, and a little over a dozen HE-177s would form the operation's long-range striking power. The assault on London commenced on the night of January 21, 1944, with Griffins lifting off from bases in France and the Low Countries, their coupled engines training under maximum bomb loads. For once, most of the aircraft actually reached their target. Pathfinder aircraft dropped flares over the blacked-out city, and the HE-177s released their bombs from 20,000 feet, too high for accurate bombing, but safely above the worst of the anti-aircraft fire. Crews could see fires spreading below as they turned for home. Operation Steinbock, also nicknamed the Baby Blitz, would ultimately be judged a failure due to the catastrophic losses among the medium bombers, picked off by night fighters and torn apart by anti-aircraft fire. The HE-177s were one of the few bright spots in the otherwise embarrassing campaign, with only 4 falling to enemy action during the entire operation, their high altitude and speed keeping them relatively safe from interception. However, the old curse that seemed to follow this project from the very beginning quickly reasserted itself, and flight readiness rates plummeted as the tempo of operations increased. One disastrous night saw 13 HE-177s roll down the runway bound for London. Once over the channel, the formation began to unravel. 8 had no choice but to turn back, gauges climbing into the red, engines coughing smoke that filled the cockpits. In some aircraft, flames covered their nacelles, crews yanking the handles and diving steeply in the hope of snuffing them out. Of the 5 that pressed on, 4 managed to drop their bombs over the city. The 5th never arrived, vanishing into the dark waters below, most likely due to engine failure. During this operation, the Allies first got a direct look at Germany's only long-range bomber. Knowledge of the Greif's existence dated back to 1940, when captured Luftwaffe personnel revealed details about the bomber's unusual characteristics during interrogation. During Operation Steinbock, anti-aircraft fire brought down one of these bombers over English territory, providing intelligence officers with their first opportunity to examine the machine that had remained largely mysterious for years. By early March, with aircraft availability below 20% and crews exhausted from the strain of flying machines that might immolate them at any moment, Operation Steinbock was quietly terminated. In early 1944, Heinkel tried yet another revision, promising better cooling, fire suppression, and sturdier landing gear. But constant tweaks only slowed things down, and only a handful were finished before the project was dropped. Attention then shifted to a new variant that would finally abandon the coupled engine concept that had caused such misery, instead counting 4 separate engines in conventional nacelles. Meanwhile, in January 1944, someone in the Luftwaffe's Weapons Development Office had an ambitious idea. That month, 5 HE-177A5s were pulled from service and gutted out their bomb bays and fuel tanks to make space for something that looked more like a field artillery experiment than an aircraft weapon. Engineers crammed 33 obliquely mounted 8.3-inch rockets into the fuselage, weapons adapted from the Naval infantry barrage system, and cousins of the BR-21 rockets already tried on fighters. The tubes angled upward at roughly 60 degrees, and slightly to starboard, allowing a single aircraft to unleash a storm of spin-stabilized rockets into a dense bomber formation. Crews could fire them individually, in salvos, or all at once. 30 rockets in one devastating broadside. This new model was nicknamed the Großdestroyer, the Big Destroyer. Early tests at the Baltic Training Center in Tarnowitz showed promise. Balloon targets disintegrated under full salvos, shredded by the concentrated barrage. In theory, the HE-177 would trail beneath an American combat box, about 6,500 feet lower, slide to the port side, then trigger all 33 tubes in a single upward broadside. The rockets would saturate the formation so completely that evasion became simply impossible for the enemy. However, practice told a different story. The heavy, fire-prone HE-177s struggled to maneuver into position. By then, American escort tactics had evolved. Long-range P-51 Mustangs swept well ahead of the bombers, hunting anything attempting to intercept. Several daylight sorties were flown, but the Großdestroyer never fired its rockets in combat. Crews found themselves chased off or forced down before they could line up. As American fighter coverage grew increasingly dense through early 1944, with Mustangs now escorting bombers deep into German airspace, the entire Großdestroyer concept was abandoned. Until 1943, the Air Ministry refused to permit any fundamental redesign of the basic HE-177A configuration, despite mounting evidence of its failures. Every request to abandon the coupled engines was rejected, every plea to eliminate the dive bombing requirement denied. Then, during a crucial meeting with representatives from the German aircraft industry, Hitler himself demanded a bomber capable of striking London by day or night, while remaining beyond the reach of Allied interceptors. An aircraft with sufficient range to hunt Allied convoys far out in the Atlantic approaches. When Ernst Heinkel stood and claimed his proposed HE-177B could fulfill these requirements, he received immediate authorization to proceed with development, regardless of the Air Ministry's objections. Working under intense pressure, Heinkel's engineers pulled a standard airframe from the production line and began reshaping it completely. The troublesome engines that had cost so many crews their lives were stripped out and replaced by 4 individual power plants mounted in traditional nacelles. With this change, at last the heavy bomber had the layout it should have possessed from the beginning. Even the first test flights proved the change. The aircraft handled better, climbed faster, and stayed aloft without the constant threat of engine fires. As production tools were ordered, assembly lines prepared, and crews began training on mock-ups, reality intervened. As the summer approached, with Allied armies breaking out of Normandy and Soviet forces crushing Army Group Center in Operation Bagration, the entire heavy bomber program was abruptly cancelled. Germany needed fighters to defend the Reich, not bombers for missions that would never be flown. Only 8 HE-177Bs were completed before workers were reassigned to fighter production. By June 1944, only a little over 24 HE-177s remained on the Western Front, scattered across airfields in France. As Allied forces stormed the Normandy beaches on June 6th, these were the only German bomber units left to contest the upcoming invasion. Operation Overlord's first night brought the HE-177s into action, armed with Henschel HS-293 radio-guided glide bombs, attacking the massive Allied fleet anchored off the coast. Before dawn, at least 5 aircraft were gone. British Mosquito night fighters accounted for most of them, with Flight Officer Fred Stevens claiming 2 between Cherbourg and Le Havre. Both bombers exploded and fell into the Channel, each carrying a pair of the 1,100-pound guided weapons. Nearly a dozen German airmen were lost that night, among them Oberlieutenant Siegfried Müller, a veteran of over 50 Atlantic missions in Focke-Wulf FW-200 Condors. Daylight on June 7th brought no respite. Lieutenant Sam Wilkerson spotted an HE-177 Griffin just as it flew northeast of Vendôme in his P-51D Mustang. On board, Unteroffizier Hubert Hein was heading back to base after attacking shipping when he transmitted, quote, "I'm going to land in 2 minutes." But before he could do so, Lieutenant Wilkerson rolled his Mustang right onto the bomber's tail and fired a steady burst from his .650 caliber guns. As flames erupted from one of its engines, the Griffin banked sharply, losing altitude fast. Moments later, it plunged into a field near Saint-Laurent-du-Bois, where there were no survivors. The losses continued through early June, as the Allies began to push into northern France. Formation struck Seine Bay on June 8th without losing a single aircraft, but the following day, 3 more were lost. Mosquito pilot Flight Lieutenant Bob Cowper caught one carrying 2 HS-293s. June 10th proved to be the worst day of the week. Though 5 additional He-177s were downed, one barely managed to release its glide bomb before it fell. The missile tore through the aft cabin of the Liberty ship SS Fort McPherson and buried itself deep in the coal bunker without detonating. When the smoke cleared, Captain Arthur Burdett and Corporal Fred Jackson of the Royal Engineers climbed down to find a live 1,000-pound bomb resting right on top of the fuel supply. Without waiting for orders, the duo heaved it overboard, earning a George Cross for their valiant actions. Unteroffizier Werner Neuenfeld and his crew experienced the nightmare firsthand on the night of June 12th. Departing Toulouse for an attack on shipping, his He-177 was intercepted by a Mosquito night fighter. Pilot Officer Len Kearney opened fire at 500 feet. Shells smashed through the radio equipment between radio operator Franz Komen's legs, missing him entirely before passing between flight engineer Helmut Kappenstein and Neuenfeld in the cockpit. Komens yelled into the intercom, quote, "Werner, the aircraft is on fire. We have to get out." From one second to the next, the entire starboard wing route erupted in flames. Neuenfeld tapped Kappenstein's head and pointed down. All 6 crew members bailed out at 9,000 feet. Rear gunner Eric Richter's straps tangled during his escape, causing him to suffer a severe concussion when he finally got out. Kappenstein landed on the beach between dunes. Komens came down in a bush, where a German soldier collecting his parachute informed him he'd landed in the middle of a minefield. Behind them, the He-177 hit the ground with an explosion so large it shook the Mosquito at 6,000 feet. Kearney and his radio operator, Norman Bradford, barely made it back. Return fire from the burning He-177 hit their Mosquito, setting their port engine ablaze. Losing altitude, the control directed them to an emergency landing strip on the beachhead. On their second attempt, the Mosquito hit wheels up, sliding until it struck a fire tender at the end of the runway, mortally injuring the driver. Ground attacks compounded the aerial losses. An early morning strike on Bordeaux-Mignac on June 15th destroyed 5 He-177s and an FW-200, with another 5 aircraft damaged. Crews were sent back to Germany to collect replacement airframes. By June 22nd, the surviving units could muster only 12 aircraft each. June's accounting was even more brutal. 37 aircraft lost to enemy action in less than 3 weeks. No recorded attacks occurred between June 14th and July 3rd. On the night of July 4th, 14 He-177s struck shipping in the Orne estuary. 8 HS-293s were launched, claiming 2 hits, though 4 more aircraft were lost to Mosquitoes. Among the dead was Oberlieutenant Jürgen Hauke, shot down for the 3rd time, but this time with no rescue. This terrible attempt marked the last Griffin mission over Normandy. Surviving units withdrew to Germany, with some crews transferred north toward Norway. Even the withdrawal proved deadly. On July 9th, Werner Neuenfeld's crew, flying one of the few serviceable He-177s north, was jumped by P-38 Lightnings. Fuel tanks ignited, flooding the fuselage with burning gasoline. Neuenfeld, Komens, and Kappenstein bailed out with severe burns. The bomber crashed east of Bourges, ending the life of passenger Unteroffizier Franz Weinreis. By August, fuel shortages and Allied air superiority had ended meaningful operations. Plans to re-equip with Me-262 jets never materialized. Griffins continued to languish at Norwegian and German airfields, grounded by a lack of spares and fuel. Crews scattered to other units for the war's final months. Germany's only operational heavy bomber had burned itself out over the beaches of Normandy. In the end, total production reached 1,137 aircraft. Of these, roughly 200 achieved something resembling operational status, though readiness rates rarely topped 30%. More were destroyed by their own engines than by enemy action. Ground crews found aircraft burned out on handstands during routine engine runs. Others crashed on training flights when engines failed without warning. The numbers told the story the Luftwaffe refused to hear. The aircraft built to bomb Britain destroyed more German crews than Allied targets.